as long as you didn't draw that one. All right, very good. All right, here we go. Folks, we're looking at, it was Mariah. Mariah. Come on now. Here we go, section 9-6. We are talking about solving rational equations. That's what we're going to talk about today, okay? Rational equations. Do you remember what rational numbers are? Rational, what is that? I make connections to things from earlier, things that we, prior knowledge, things that we already know. Rational is talking about a set of numbers, real numbers, whole numbers, natural numbers. But when we're talking about rational, for whatever reason, and I don't know why I make this connection, but it's an easy connection for me to make to my friends, the fractions. My friends and yours. We love fractions. Yes, we do. We love fractions. How about you? How about you? How about you? Okay? Right then? Enunciate. Okay. All righty. I need to enunciate. Thank you. I know that nod was with love. Yes, ma'am. Miss Perry, you need to enunciate better. Speak more clearly. Again, get me now. When you need to. Rational numbers, folks. Rational numbers are fractions, and I know that some of you love fractions as much as I do. I can see it in your faces. I know you do. Now, what the title of this section is solving rational equations. That means we're going to be solving equations that are in the form of our friends' fractions. It's fun, and you're going to love it. You're going to love it. You're going to smile, and it's going to make you feel better about these rational equations, which are fractions. So just embrace it, smile, it'll make you feel better, and just don't go into it thinking, I hate fractions. Don't go into it with that attitude. Don't. Smile. Smile. It's all good. Here we go. Folks, the things that we're going to have to do is we're going to have to solve and check. Okay? Solve and check. It's kind of like what we've already done. Kind of, sort of. And I will tell you, if y'all know I don't have any problem working with fractions. I like them. But there are times when I want to work with fractions, and then there are times that I want to get rid of those denominators. And there are a whole lot of times y'all want to, right? So if we were just to start with something very simple, if I were to have 3/5 and 4/15, okay? This is like pre-work. We're not solving and checking anything yet. We're just kind of reviewing what we already know about fractions. Sorry. But how would I even begin to solve 3/5 plus 4/15? Common denominators. You know that your common denominators, bless you, going to be 15, right? What number? Now, that we've done this kind of already. How did I change 5 to 15? I multiplied by 3. So if I multiply it to the bottom, I have to multiply it to the top. Now this 3 is coming straight down. So let me make that like that. And then I'm multiplying my 3 in green, which is the 3 that I multiplied to 5. Because what I do to the top, I have to do to the bottom, right? Does the second fraction have to change at all? No. We leave it 4/15. We get 9/15 plus 4/15, and we get 13/15 is our answer. And then we reduce if possible, right? But that can't be reduced, right? You guys remember how to do this, right? Now, I'm going to throw a twist in there. Just a little twist. What if I had 3/5 plus 4/15 is equal to 1. Taking baby steps. You have to do what now? Say it again. Oh, hold up. Well, that's not 1, is it? But what if I were to put x? What if it was x over 15? You did these equations in Algebra 1. You didn't like them. You didn't like them then, you don't like them now, okay? But you're going to get better, and you're going to be more comfortable with them now. No, not proportion, because remember, a proportion is one fraction equal to another fraction, okay? And I've got 2 pieces on the left here with 1 piece on the right. Yes, ma'am? Okay. Still want to go with those common denominators, all right? All right, so still, folks, on the left side, our common denominator is going to be what? It's going to be 15. Hands down, you know it. X over 15 is not going to change, right? What do we multiply to 5 to get 15? 3. If I multiply it to the bottom, I have to multiply it to the top. So I'm going to have the 3 that was already there times the 3 that I multiplied to the top, right? Okay? Is equal to 1. Could what? Could I put 15 over 15 for 1? Why? Because 15 divided by 15 is 1, and it would have all 3 pieces of my equation having what? Common denominators. So I can change 1 to 15 over 15. They are equivalent. Now I'm going to combine 3 times 3, which is 9/15, plus x 15ths is equal to 15 over 15. Ooh, I could show you. Oh, this is going to make y'all crazy. What can I combine? Can I combine the left side? Look at it really closely, because we've been doing this to prepare for trig. Oh, there's a couple different ways. Couple different ways to do this. What did you say, Ted, that you want to do? Subtract 9/15 from both sides. All right, that's one way to solve it. I'll show you a different way here in just a minute. That just hit me. 15/15 minus 9/15 is what, y'all? What's 15 minus 9? 6 over 15. And then if we were going straight up algebra 1, then we would multiply both sides by what? 15. Because we're multiplying by the reciprocal. And that crosses, that eliminates my 15's on the left. It also eliminates my 15's on the right. That just happened to be there. I didn't make that happen. It just coincidence. And that's going to leave me with 6, right? How would I go back? Yes, sir? Let's take that problem. This is method number 1, right? Okay? This is method number 1. So, Nathan, you don't want to work with that fraction at all, do you? And you want to get rid of it, right? All right, so here, same problem. Let's look at a different way. Now, folks, you have to decide. You have to understand that there are several different ways to solve this. Okay? Several different ways to get to the answer. I don't care how you get to the answer as long as you get there. All right? Some of you will go this way every single time, like we did in method 1, and you will be fine with that. If you are, do it. Okay? Nathan and several of you others are like, no, I am not dealing with that fraction. So you're going to solve it this way. Nathan, at this point, this is when you would say, method numero dos, 9/15 plus x over 15 is equal to 1, right? What do you want to do to both sides of that equation? Why? It's going to get rid of every one of your denominators, wouldn't it? All right? So I'm going to multiply everything. Now, here's my thing. You can get into some careless mistakes, and this is where I don't want you to go. I need to think for me, for hope, that I'm distributing that 15. Okay? When I distribute that 15 to 9/15ths, folks, what's going to happen to my denominator? It's going to cancel out. And I'm going to use black to do that. When I distribute 15 to x over 15, what's going to happen to my denominator again? It's going to cancel out. But when I distribute 15 to 1, it's going to give me what? Plain old 15. So it gives me 9 plus x equals 15, correct? Hey, we're back to something we're comfortable with, aren't we? I mean, you guys were learning this in the 6th grade. How do I solve it? Of course, subtract 9. Hey, do we get the same answer? Yeah, we get the same answer. Absolutely. It still would have left you with 15 on the top. What if this would have been a 2? Well, you'd have gone 15 times 2 is 30, right? It doesn't matter what it is. You still just multiply that number, okay? There's another method. I'm thinking from the perspective of what class do I typically, or have I typically taught forever and a day? Geometry, right? Okay? I'm thinking from a geometrical standpoint, and what are the things we deal with a lot in geometry? Proportions. All right? Check this out. Method number 3. Same problem. I'm going to go with the same place I started in method 2. 9 over 15 plus x over 15 equals 1. Okay? Watch this. Remember I told you how I'm trying to prepare you guys for trig? If I have like denominators, can I add those numerators together? Yeah. So I have like denominators here on the left. Do I not? Can I literally add 9 plus x together? Or do I smash them together, or do they have to be connected with a mathematical sign? They have to be combined with a what? A plus sign, okay? So I can say 9 plus x, one numerator, over one denominator, is equal to 1 over 1. Can I? If I can write 1 as 15 over 15, I can write 1 as 1 over 1, right? Now, think about where I'm coming from. I'm coming from geometry and proportions. Do I have a fraction equal to a fraction? Yes. How do you solve proportions? You cross multiply. Check this out. 15 times 1 is 15. What's 9 plus x times 1? I'll be daggone. What's my answer? Still 6, isn't it? More than one way to skin a cat. Okay? I tend to go to proportions. Some of you are going to go to the fractions, like we did in method 1. A whole lot of you are going to go, I ain't dealing with them fractions. And you're going to go eliminate the fraction altogether. But I want to show you with something simple how you get the same answer no matter what you do. Now, could I check and see if that's right? Yeah. Take your calculators. Let's see. Our original problem. Calculator. 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 Okay. Check this out. I know that 6 is my x, right? We've solved it 3 times. It better be right. Do you guys agree? Watch this. Parentheses, 3 divided by 5. There's 3/5 plus what? 6/15. 6 divided by 15. It better equal what? Check that out. Kind of cool, huh? Now, we started with something very, very simple, folks. And the reason I started with something simple was I want you to be ready when we go to more difficult equations. But that's all you have to do. Throw that value in, check it with your calculator, and you're good to go. Say it again.
Since the third over 15, can you just do it like you're going to and leave it like that and not have to worry about the fraction on the bottom of the zip over?
I don't understand what you're asking. Hold on. It's time. I want you to understand, I'm not going to force you. I cannot, y'all. I cannot in good conscience say, you're going to do the problem my way. And if you don't do it my way, I'm going to count it wrong. I cannot do that. I cannot, and maybe I'm a bad teacher for doing that. I cannot force you to do a problem my way, because my way is not always the easiest way for you, okay? If you were to ask any of the math teachers, we all might show you something different. And that's okay. But I want you to solve it, any of these equations, the way you're more comfortable with, the way that it clicks with you in your brain, okay? But several different methods out there. Just get ready. All right, here we go. So let's solve and check. Solve and check. And folks, you can put this stuff right in your calculator to figure it out. Let's start with 4x minus 3 over 5 minus 3 minus 2x over 3 equals 1. Now, is anybody seeing anything? Are you hearing bells and whistles in your head? All right, well, common denominator. Anything else that's kind of glaring at you like, oh, I better be careful. Tricky, tricky. With the negative where? Which negative? The subtraction symbol in the middle, okay? Beware of subtractions, okay? You know could we what? Yes, you can. You can do that. Absolutely, you can do that. If you want to take care of that now, then let's take care of that now. Because subtraction is just adding the opposite, isn't it? So could I technically rewrite this problem, 4x minus 3 over 5, plus the opposite of, be careful, the quantity 3 minus 2x. Now, notice the way Ted said it. He said, can I just go on and distribute? Well, what's he going to distribute, y'all? A -1, okay? This is the blue. You might want to put this right here. Beware of subtraction, okay? Because now we're going to distribute. Probably we should do that every time to begin with. We all should do that together. Well, yep, -1 times +3 is -3. -1 times -2x is +2x. Now we're safe, right? And oh, look, how convenient. What's our denominator? 5 and 3. Oh, wonder what that's going to be. 15. Wonder if there was a purpose that Miss Perry started with 3 and 5 on the other problems. Maybe. Maybe. Common denominator is going to be 15. Do you guys agree with that? Yes? All right, so here we go. Let's make some changes. 15 is our denominator. Go ahead and write down 4x minus 3. Please, just for your notes, write everything down. Some of you, I know you're going to do a whole lot of mental calculations, and that's fine. I admire you for doing that. But just for your notes, put every step in there, okay? Create good habits. What am I going to multiply to the top of this fraction? Y3. Because that's what I have to multiply to 5 to get 15. So 3 is on top. I got 15 here. I'm going to take negative 3 plus 2x. And I'm going to make that a 3. What are we multiplying to the top of that second rational expression? 5. And then what do you want to do with 1, folks? You can rewrite it 15 over 15. You can leave it at 1. It depends upon the way you solve it. I'm going to write 15 over 15 just because. And now, distribute. Those numerators, distribute the numerators. Okay? I have the luxury of having colors. Some of you are very visual like I am, and you should have colored pencils out on your desk every single day. All right, so here we go. When we distribute, we're going to get 12x minus 9 over 15 plus, you tell me, negative 15 plus 10x over 15 is equal to 15 over 15. All right, what do y'all want to do? You want to go one numerator over one denominator. How many of you want to eliminate the fractions completely? Hey, don't roll your eyes at me. How many of you, hands up seriously, because we need to make a decision as a class. How many of you want to eliminate the fractions? Hands up high. I would say, how many of you want to go proportions? Just a few of us. Okay. All right. Eliminating, y'all are like snickering. Ha, 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 Miss Perry. If you want to go proportions, those of us in the proportion club, high five, first of all. We're our own special club. But if we're in the eliminators, then let's eliminate just to appease everybody. If you want to proportion, you proportion on your papers. That sounds like something ugly, but you know what I'm trying to tell you, okay? Here we go. Eliminators, what am I going to multiply everything by? 15, okay. I'm going eliminators on the, I'm going to have to watch this video myself just to laugh. All right. So my denominators all cancel, don't they? Can you believe I'm recording, eliminating this? Allie G, you better be proud of me. You are? Oh, yes! Yes. My job is done. Yes. Solve. You don't need me to talk you through this part, but I'm going to for the recording. Combine like terms. So 12x plus 10x is 22x. Negative 9 plus negative 15 is negative 24. Equals plain old 15. Right on. Nate, am I right? Yeah. Oh. Really? Yeah. Ooh. Keep solving, and then take a look up. Did we really get that ugly? That's an ugly, nasty-looking fraction. 39 over 22? How many of you had that? Hands up. All right. Did we simplify that? Is there any way to simplify it? No. Pardon? Yeah, it's an odd number over an even. We can't really, yeah, it's not divisible by anything. What do we do now? How do we, because we have to check it. We have to check it. Where are we going to put this value in? The very first one, okay? And I'm telling you, actually, would we want to put this in the first one? We could. Be a lot of work in the calculator. But since it's just a manipulated equation, folks, couldn't we actually put it in this one? Let me put this in green. Couldn't we check it here where we eliminated? Those of us that eliminated. If you're a proportion person, you would just put it back into your proportion, okay? But put this in your calculator. Heck, put it in this one, because that's after we've combined like terms. 22 over 1 times, I'm going to do it on paper. I don't need this stinking calculator. Is 39 minus 24 15? Yeah. So I know I'm right. Thank you. Right on? Everybody cool with that? Facile? Difficile? I see. How many of you say, not so bad? How many of you say, let's just try another one and see how it goes? Yeah, me too. All right. Questions at all? All right, so if you're eliminating, this is like a game. We have the proportioners, and we have the eliminators, and we have the fractioners. You're not going to fraction. I knew you wouldn't. You're going to. All right, here we go. Let's try another one. Notice what kind of number we had in that first problem. The denominators. We had real numbers, didn't we? We had monomials that were actually just constants, correct? How about this? Taking it up a step, taking it up a level. 9 over 28 plus 3 over x plus 2 is equal to 3/4. Now, y'all know I get all messed up with what I've covered with y'all, what I've covered with trig, because the first part of trig is all Algebra 2 review. We've gone over rational expressions, but we have not gone over the equations, correct? Look at that. What can x not equal? Straight up cannot equal. What can x not equal? Look at that. Write it on your paper. What can the value x not equal? Because if it does, why can it not equal -2? X cannot equal -2. If we had x is equal to -2, folks, then that's going to put 3 over -2 plus 2, which is 3 over 0. And what is any number divided by 0? No. If 0 is under the fraction bar, then the number is undefined. Okay? So that would give us an undefined value. So x cannot equal -2. That's important to us. We'll have to put that in our final answer, okay? So if you ever have a variable in your denominator, you better find out. Now, how would I find out? Folks, all you have to do, bless you, is take that denominator, bless you, and set it equal to 0. That's all. Take that denominator and set it equal to 0. What was it, x plus 2? And solve, and hey, that's how we got -2, okay? That's what you do. Set your denominator equal to 0. So you got to do a little pre-work before we do the real stuff. Bless you. Okay, here we go. We got 28. We got x plus 2, the binomial, and we got the number 4. Let's take it in chunks. What would the GCF, what would the common denominator be for just the plain old numbers, the constants? Bless you. Got it? Tell me when. Okay. Good? Okay. What would the common denominators be just for those constants? 28. All right, time out. All right, here we go. 28 for the number. '28's taken care of. My constants are taken care of. What about that binomial? I got to multiply that binomial to every single denominator, don't I? Yeah. All right, so I got x plus 2, x plus 2, and x plus 2. Because it's all part of it, folks. It's all part of it. Take a deep breath. Here we go. What do we multiply to the bottom that needs to be multiplied to the top? Go ahead and write down the 9. Write down the 3. And write down your 3. Go on and write it down. Go on and get it out of the way. Because if we don't do it now, we'll forget. Forget. F-O-R-G-E-T. Forget. We will not forget. Okay? Here we go. What do we multiply to that first denominator? We multiplied x plus 2. If we multiplied it to the bottom, what do we have to do to the top? We have to just multiply it to the top.
I mean, like, why did you multiply it to the 28?
Because it's part of the denominators. When we start this problem, we're starting with our denominators as 28, x plus 2, and 4.
So if you have something like that, like x plus 2 or something like that,
you have to throw it in that denominator to begin with. Now, are we going to become eliminators? Yes, and we're going to eliminate. And you kind of, sort of, feel like you're chasing your tail a little bit. And we are, in a way, but this is just what we have to do in order to get rid of everything, okay? All right, so look at the second fraction. What changed from x plus 2 to this denominator down here? We multiplied by 28. If I multiply 28 to the bottom, what do I have to do to the top? Multiply 28. That's what's different. Okay? Now, what did I multiply to the next fraction? Well, we got the binomial and what other number? 7. Why? Because 4 times 7 gives 28. So 7's up there. And the binomial x plus 2. Right on? All right, let me put that in black so you can see it against all the rest of that. I need a bigger smartboard. Because 4 times 7 gave us 28. X plus 2 gave us, nope, that's okay. You got to think it out loud. Think it out loud. Now, folks, what do you know we're going to do? We're going to distribute all of our numerators. And what are we, in essence, going to do with our denominators? What's going to happen to our denominators? They're going to eliminate. So why? Because we're going to multiply one side and we're going to distribute, and it's going to eliminate all of our denominators, won't it? So can I go ahead? Let's distribute our numerators with a green. 9 times x, 9 times 2 is 18. I'm not going to distribute my denominator. You're going to appreciate this step here in just a second. What's 3 times 28?
24.
And then, folks, what are we going to distribute on that right side? Am I going to distribute 3 and then 7, or am I going to distribute the product of 3 and 7? The product of, which is 21. So we're really distributing 21 to x plus 2. So 21x plus 42. You guys agree with that? Yes? All right. Look what I did. 3 times 7 is 21, and I distributed 21 to that quantity to get 21 plus 40, 21x plus 42. Folks, what are you eliminators going to do right now? You're going to forget about that denominator, aren't you? Are we done with the denominator? We're done with the denominator. Guess what happens? Just drops out of there. Okay? We could mathematically distribute to all of them, physically cancel them all out, but from this point on, your denominator can just drop out. You know what it's like? It's kind of like we use and abuse it. We have to have common denominators so we can mess with the top. So we kind of now we're just kicking to the curb. We're done with you. Bye-bye. Y'all know those people who'll use you to get what they want. Then they done. That's what a denominator is. It's kind of what they're like. So the denominator just drops out. And it does so because we could distribute that denominator to every single thing in that rational equation. But now I'm just going to write 9x plus 18 plus 84 is equal to 21x plus 42. And folks, from here on out, you better get the right answer. You better get the right answer because this is Algebra 1, folks. 9x plus 102. Is that right? I'm going to subtract 9x and then subtract 42, which is going to give me 60 equals 12. And I'm going to divide by 12. So x is equal to what? How many of you got that? Okay. X is equal to 5. Okay. I'm sure there is a mathematical way. X is equal to 5. And I'm going to check on this. X cannot equal negative 2. It's equal to 5. It cannot equal negative 2 because if it equals negative 2, it makes our number undefined. And with that, we can't do that. I'm going to check on the mathematical proper way notation, okay? But for now, we're going to leave it like this because that is the correct answer. X cannot equal 2. It does equal 5. And it can equal 5. Where do we check it? Where do we go back and check it? You can go back to the very beginning and put in your calculators. And I'll just do it because I'm here. But my calculator's batteries are dead again. I don't know why I have to do this. What would our denominator be now, y'all? I got 9 divided by 28 plus 3 divided by what? What did we find? We found x to be 5, so that makes that denominator 7. Y'all with me? Is 0.75 equal to 3/4? Yeah. Do you see how you can also, what are we going back to every single time? The calculator to check it, right? Nicil or difficile? Everybody cool with that? Questions at all? Need to stare and compare a little bit? Let's go with one more. One more. Aha. Ha ha ha. This one's good. 3 over x plus 2 is equal to 5 over x plus 5. This is when I become a forest person. Tell me why I become a forest person on this problem. Oh, I can do this. What does that mean? That is the universal sign for proportion. It's a very exclusive club if you can do that, Quentin. Yes. Why did I say you become a forest person? Because if you step back and look at it, isn't it a proportion, folks? Proportion. Happy, happy, joy, joy. Proportions make me happy. And just like Quentin said, we do that. We cross multiply. So easy. First of all, bless you, what can x not equal? It can't equal, look at the left side. Can't be -2 or -5. All right, let's see. 5 times x plus 2, 3 times x plus 5. Here we go. Distribute. 5x plus who? 10 is equal to 3x plus 15. And then let's solve. 2x is equal to 5. How many of you got x is equal to 5/2? Hands up. Facile or difficile? Hey, bring on the proportions all day long, right? I love those. Those are easy. Easy, easy, easy. And we got x is equal to 5/2. Well, x cannot equal -2 or -5. For now, I'm going to say yes. I may drop back and punt on Monday. Okay, we don't ever want our denominators to be, we don't ever want our fractions to be undefined. So in order for us to have that, then I have to say that x cannot be equal to -2 and it cannot be equal to -5 as well. Okay, what do you think? Is it that bad? Bless you. Is it all right? I want you to get started. And look, I know we only did 3 problems, but we did one problem 3 different ways, didn't we? Okay? I want you to look at page 123. We're going to finish this up on Monday. I promise I will have those tests graded for you. Okay? On 123, let's go with let's go with 1 through 9. I'm going to put you in a and then I'm going to go. All right, look at, I don't care. Look at number 4. Look at number 4. Let's do 4 together because it's kind of weird. Section 9.6, it's page 123, of course, in your workbook. My fault. I don't ever want you to take that big old book. This is called Solving Rational Equations. Yeah. Oh, smarty McFarty. 3 minus z. Look at this. Good, Ted. Good forest person. Why did he just go forest on this problem? Put that over 1, y'all. Can I put both of those over the same denominator of 1? Well, yeah, because what would this be? 3 over 1 minus z over 1. If I combine that into one fraction, what would it give me? 3 minus z over 1. And then what could you do? What could you do? Y'all, what could you do? What is that? Oh, back at you in decay. Proportion. That is a straight up proportion. Are we going to freak out that we're going to distribute a z? No, we're not. Z times 3 minus z is equal to plain old 2. Look at there. Looky dar. What are we going to do now? We're going to distribute. All right, we're going to have z times 3 is 3z. Always put your coefficient first. Z times negative z. Negative z squared is equal to 2. We are not going to scream and holler and run for the hills. We're going to tough this out. What do? Oh, we're going to make this, what kind of equation do we have now? We have a quadratic. How do you know it's a quadratic? Because it's an x squared or a z squared term, and we're doing exactly what you just got finished doing on the test yesterday. Look at there. How do we do that? Add z squared, because we never want a negative leading coefficient, do we? Can I also subtract 3z from both sides? Yes, because I want to set it equal to 0. And I want to put it in descending order to make it look nice. So z squared minus 3z plus 2. Everybody with me? You could have, and then you would have had to divide by -1 because you would have had that leading negative coefficient. And I don't ever want to do that. But it's doable, okay? Folks, solving quadratics. You can throw that in your calculator. You can complete the square. You can, what else? You can quadratic formula, or you can factor it. Are there 2 factors of 2 that when you add give you 3? What are they? 2 and 1. Are my signs same or different? Same. They're both going to be minuses. Hello. If those are your factors, what are your solutions? 2 and 1. All right, let's go back and look at our first fraction. What can 2 not equal? Not 2. That was stupid. I looked at the z. What can z not equal? Because z's in our denominator. Over here, z cannot equal 0 because I don't ever want a 0 in the denominator, correct? Where z cannot equal 0. Only in the denominator, that's right. And that's why I drew my arrow there. I know these notes look crazy. I know what I mean. And I hope you do. That's why I use so many beautiful colors. Okay? And then you could go back and check it. And it should have one side equal to the other side. Right on? What do you think? Not too bad? Is it doable, y'all? Yeah? Get on it now. Okay? So now you only have 8 problems, Dante. You're welcome. Have at it, folks.